We're going to do a couple examples of this video. These examples are taken from the Google slideshow that I've embedded with this lesson. If you're following along without that lesson, just watch for fun. Hopefully you kind of get a little bit more understanding in how to calculate pH from hydronium concentrations, and then in example 2 we'll look at how to calculate pH of a strong acid when after the acid has been prepared from mass and volume and all that stuff. So let's start with example 1. It's asking calculate the pH of a solution that has a hydronium concentration of 3.8 times 10 to the negative 3 moles per liter. And then it's asking, is the solution acidic or basic? Well, I can calculate pH using the formula of taking a negative log base 10 of the hydronium concentration, like that. So this question's pretty straightforward. I just have to substitute the value of my hydronium concentration directly into this formula. And that value is 3.8 times 10 to the negative 3, like that. And this is a little tricky to do in your head, so I'd recommend using a calculator for this. Remember, what we're doing here is we're trying to figure out what exponent, when applied to 10, gives us this number. So thankfully, we can figure out that exponent, that logarithm, I should say, by taking the negative log base 10 of this number. So press the negative sign, then log. There we go. That's a little bit more visible on the screen. And then I'm going to write in that number, 3.8 times 10 to the exponent minus 3. I'm going to jump back down and add some closing brackets. And I get a value of 2.42. So that tells me that it's pretty acidic, 2.42. Now, the rule for significant digits is that the number of significant digits I have in the hydronium concentration is equal to the number of digits I place after the decimal point in my pH. So really the only significant digits inside my pH are the 4 and the 2. Remember, the first 2, the one that comes before the decimal point, is really just referring to an exponent. It's kind of telling us around what power of 10 this acid is located at. So the 2 is really just referring to an exponent. If you looked at something that had a pH of 2, its hydronium concentration would be 10 to the minus 2. Well, that's actually equal to 0.01. Notice how there is no 2 in 0.01. There is no digit of 2. Where is the digit of 2? Well, the digit of 2 is really just showing us that we need to be 2 decimal places to the decimal point needs to be placed 2 decimal points to the left. Okay? So the 2 is really just telling us how many places do we need to be away from the decimal. So that's why the 2 is not a significant digit. The only significant digits are the ones immediately to the right after the decimal. So that's why I'm going to round to 2 decimal places, 2.42. I have 2 significant digits right here. So those are my significant digits, 3 and the 8. So that means I need to have 2 digits after the decimal in my pH final answer. So this gives us a pH of 2.42. Is it acidic or basic? This is definitely acidic because it's less than 7. All right, pretty easy example. Let's move on to example 2. This one's a little trickier. We're not given a concentration, we actually have to figure out the concentration. So the question says, calculate the pH of a solution made by dissolving 3.75 grams of hydrogen chloride in enough water to make 250 milliliters of solution. Is the solution acidic or basic? So when we make hydrochloric acid, we take hydrogen chloride and we dissolve it in water, like this. We add it to water and we end up getting hydrochloric acid. It's dissolved in water, and I'm just adding the plus water here. You know, I could have just written it right there at the top, but we make hydrochloric acid, and then hydrochloric acid, as you might recall, then will react with water molecules around it to make hydronium ions. And hydrochloric acid is a strong acid, so that means we can assume it goes to completion. This reaction goes to completion. So we consume all of these hydrochloric acid molecules, and they all give away that hydrogen to water to give us hydronium ions. So what this allows to do when we calculate pH is to take whatever amounts I have of hydrochloric acid and convert it straight into hydronium ions. I can imagine there's a coefficient of 1 here and a coefficient of 1 if I were to write the balanced equation, which I have. We don't need to write the ones, but it's a 1-to-1 ratio. I'm making, for every mole of hydrochloric acid, I make 1 mole of hydronium ions. So whatever amount I calculate here, it immediately applies to hydronium. This is only true for strong acids. If you take chemistry 30 or grade 12 chemistry, you'll learn a little bit more about equilibrium and how to handle weak acid pH calculations. Those are a little bit trickier, and we can't use the logic that I just outlined with weak acids because they don't go to 100% completion. So let's at least handle this example. It tells me that I've got 3.75 grams of hydrogen chloride, and we dissolve it in 250 milliliters of solution. So I need to convert that to liters. So what I want to do is express my concentration in moles per liter. So I need to take my mass of hydrogen chloride and convert it into moles of hydrogen chloride. So the number of moles of hydrogen chloride are going to be 3.75 grams. And I'm going to write my molar mass conversion factor here. And the molar mass of hydrogen chloride, I believe, let's see if I can do this in my head. Do I remember all the values? I think chlorine is 35.45 grams per mole, and then hydrogen is 1.01. So that gives us a, what is that, 36.46. This will be embarrassing if I don't get it. Let's just double check. I didn't get much sleep last night. There we go, 36.46 grams. So the grams will cancel out, and this will give us a final answer in moles. I'm not going to write the number out here because I'm going to keep this all intact for my final answer. So there's my number of moles. And then I know I can figure out the hydronium concentration by taking that number and dividing it by the volume. So let's go ahead and figure that one out. So my hydronium concentration will be my number of moles, which are represented by this operation. And I'm going to divide it by my volume. So my hydronium concentration is 3.75 divided by 36.46. And then I divide that by 0.250, and I'm given a concentration. I'm going to keep all the numbers in my calculator, but I don't need to worry about sig digs quite yet, not until I get to my final answer. So just for your records, that's kind of roughly what it is. How do I find my pH? To find the pH, I take the negative log base 10 of the hydronium concentration. So I'm going to take this number here, but I'm going to take the one from my calculator and apply it to the formula to get my pH. Now might be a good time to think through how many significant digits I should have in my final answer. So I'll pause the video there and think about that. Okay, so let's do the negative log of that number, and I get a pH of 0.386. And I should have a pH of 3.386 because I do have 3 significant digits in my measured quantities at the start, so I should at least have 3 digits to the right of my decimal in my final answer. All right, that's it for examples 1 and 2. I'm going to make another video covering examples 3, 4, and 5.